Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope everyone's doing all right out there. So let me just explain to you what our goals are going to be for today. Actually, we have one goal today. And what it is we're going to use the graphs of sine and cosine to understand the tangent graph. Now, I literally just spent a half hour drawing this graph. It's still terrible, but I'm happy with it. It's the best sine and cosine graph I've ever drawn. I'm really proud of it. Look at it for a second. Brilliant. All right. Anyways, I also did some approximations. Square root of 2 over 2 is roughly 0.7. 1/2 is 0.5. And square root of 3 over 2 is roughly 0.85. I did the cosine graph in purple. And again, you can see that this is an even function because it has a mirror image on either side of the y-axis, meaning the same distance left and right, I get the same height. Sine graph is in red. And this is an odd function, meaning whatever distance I travel left and right, I get opposite heights. So cosine is even, sine is odd. And I want to graph tangent in, this looks to be an aqua, but it's supposed to be a green. And I want to, it's kind of a hard thing to wrap your mind around using two graphs to graph a third. But that we have some tools at our disposal. So do remember that tangent is equal to sine over cosine. So let's make sure we have that in here. So tangent it sounds like they're having a lot of fun out there. Hopefully you guys can hear it in here. So tangent is sine over cosine. So let me explain how this is going to work. What we're going to do is we're going to take the height of the red and we're going to divide it by the height of the purple, and that's going to be the height of the tangent. Now there's a couple places that are real easy to find the heights of tangent, meaning you're dividing the same height by itself. And we have that happening here, 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 and here. So at where the sine and cosine graphs cross, we're either going to have a height of +1 because I'm dividing a positive height by a positive height, or I'm going to have this is also +1. Are they all positive ones? Huh. No, really? Interesting. Yeah, it looks like they're all positive ones. So the height of tangent at this point is +1. Because I'm dividing the same height by the same height. The height of tangent at this point is +1. Because again, I'm dividing the same heights by themselves. The height of tangent at this point is +1. Again, because I'm dividing the same height by itself. The value of tangent at this point is also +1 because I'm dividing the same height by itself. So those are some easy points to find. We got a lot more points to find, but those are pretty simple to find. Let's see here. Where am I dividing into 0? Right here. I'm dividing -1 into 0. So tangent has a height of -1. Oh, there's a -1 in there. I see it now. Here again, I'm dividing a positive height into 0, so tangent has a height of 0. Here again, I'm dividing a negative height into a 0 height, and that's going to give me a height of 0. And it happens again right here. I'm dividing a 0 height by a +1 height, and that gives me a height of 0. So we've found 8 points so far of the tangent. And so let's find a couple more points here. And here's the negative heights. So I'm going to divide a positive by its opposite. So I'm going to get a -1 right here. I knew there had to be a -1. I don't know what I'm doing. Let's see here. Here I'm dividing a positive height by its opposite. So tangent's height will be -1 here. Again, here I'm dividing a height by its opposite. So tangent will have a height of -1 here. And finally, I'm dividing I'm dividing a negative by a positive, and tangent will have a height of -1 here. Okay, so now we have a total of, let's see here, 10 points it looks like. 10? Oh, yeah, one more. I'm dividing a 0 by a height, so I get, it looks like tangent crosses the x-axis where sine does, and that makes sense because the value of sine is a numerator. When the numerator is 0, that means tangent will also itself be 0. So we know where tangent is equal to 1, we know where tangent is equal to -1, and we know where tangent is equal to 0. Now we had that earlier lesson, actually I'm going to hold off on that for a second. I now need to talk about where cosine crosses the x-axis. So we're dividing by 0. And these are going to be the asymptotes. These are the vertical lines that tangent cannot cross. So I have to draw a vertical line through -3/2. I need to draw a vertical line through -1/2. I need to draw a vertical line through +π/2. Again, this is because I'm dividing by 0, so these are the asymptotes. And I have to draw it right here as well, because again, I'm dividing by 0. We're not allowed to do that because it's undefined. Okay, I think this was the only one that I didn't put in the right spot. Again, this one, okay, graph. So now we know where the asymptotes are for our tangent function. And now I'm going to reference the ice cream lesson that I talked about prior, meaning if you're to make a spoon get smaller and smaller, having too much fun with it. If you're to make a spoon smaller and smaller, you're going to scoop more, right? So the smaller the spoon, the more scoops that we get. And we have this happening all over the graph. And so let me try my best to explain. We'll start right here. Okay? So the purple line is the spoon. And the spoon is getting smaller and smaller and smaller and smaller. So what that means is we can take more scoops. And since I'm dividing a positive into a positive, I'm going to get a very large number out of this. So again, as this gets smaller, we're dividing by a smaller number so we can scoop more. So what's going to end up happening is our tangent function is going to grow, and grow, and grow, and grow, and grow. Now, if I was to go on this side, as my spoon gets smaller and smaller and smaller, I'm dividing into a negative number. So the tangent function is going to grow in value and come down in this way. And I should have curved that a little bit more, but that's okay. Again, we're going to have this repeating pattern. And so here I have a spoon that's getting smaller and smaller and smaller, a negative spoon getting smaller and smaller and smaller, going into a positive number. So that's going to make a very large negative number. Remember, the smaller the spoon, the more scoops that we can take. And so as the spoon gets larger, we take less scoops, which means we're getting closer to the x-axis. And as we come up this way, we hit 0. And now I'm dividing a very small spoon. As I move over, I'm dividing a very small spoon into at the largest one. But as the spoon gets smaller and smaller, I can take more and more scoops. And so what that's going to do is it's going to allow this value to just keep growing and growing and growing and growing. And this is not a very good curve that I'm drawing, but it's supposed to be almost a, what would you call that? Kind of like that. And again, we're going to have, let's see here, we're going to have a denominator that's going to a very small positive number dividing into a negative number. So I'm going to have a negative behavior here, and it's going to come up like this. Again, we can't cross the asymptotes because that's a borderline, and if I cross the asymptotes, I've divided by 0, which you're not allowed to do. And so what we're seeing here is we're seeing the graph of the tangent function as a result, that's not a very good one, as a result of comparing the sine functions and the cosine functions. Hopefully this lesson is translating. It's a very abstract lesson, and you might need to watch it a couple times for it to make some sense here, but I wanted you guys to see how we could use the graph of the sine and the cosines to actually create the graph of the tangent. And you're seeing that the tangent graph, and this is terribly drawn, I'm actually really embarrassed of my tangent graph. I totally heard about that one. The tangent function you're going to see a repeating pattern. Okay, that's better. Right, so we're getting this repeating pattern, and the pattern repeats at every length of pi. And it does that because at these specific values I'm dividing by 0, so it's constantly resetting itself. So hopefully this makes some sense. I know it's a little bit of an odd lesson to discuss using the graphs to create the other graph, but we're looking at behavior. The closer, let's see, the closer this graph gets to 0, and it's negative, so the closer this gets to 0, dividing into another negative, we're going to get a very large value, so that's why we get this very tall graph at this point. So hopefully this makes sense. I'm going to end the lesson here. We're probably going to have some discussion on this because, again, this is a very abstract way to look at this, so I'm going to end the video here. Again, I hope everyone's having a good day. See you guys later. Bye-bye.